everyone hear me okay? All right, good, good. Let me know if you can't. My name's Harris Schneiderman. I've got Phil Duff with me. Today we're going to be presenting on failover clustering in Hyper-V. I'm going to talk to you about how to plan a highly available virtualization environment. Just to give you a little background, both Phil and I work for Microsoft in the office in Melbourne, and we focus on a lot of data center related technologies, including virtualization. So what we're going to cover today is how do you plan for high availability? How do you understand the support policy around virtualization and clustering? And how can you validate that what you've built is going to work and is going to be supported by Microsoft? We're going to talk about live migration, how it works, and how it's an essential part of building a highly available infrastructure. We'll help you with the deployment planning activities across your environment. Phil will talk about how you can configure your virtual machine failover policies so that if your environment has a problem, it knows what to do and recover from it. And then towards the end, time permitting, we'll talk about how to manage your data center environment with various tools, including System Center. The plan for today, I think, is we'll go through the presentation, and then probably what we'll do is we'll leave some time at the end for questions, if that's all right. All right, so planning your high availability model. High availability and failover clustering is really an essential piece of building a private cloud. It's not all you have to worry about if you build a private cloud, but it's very, very critical. Your VMs have to be able to move so that if there's a fault or problem in the environment, that you can recover from it quickly. And you have to think about how to improve the availability of your VMs across a variety of areas. So the hardware, the host OS, the virtual machine, the application or service that you're trying to make available, and then be able to recover from any faults that happen. And in order to know if there's a problem, you have to be able to monitor them and understand their overall health state. So we'll talk a little bit about that. You want to make sure your environment has flexibility in terms of how you can deploy. So essentially, you want to make sure that your VMs can be deployed in the optimal configuration given the scenario that you have in mind. And it needs to be resilient for both planned downtime, like patching and scheduled maintenance, as well as unplanned downtime, such as a fault or a problem or an outage of some sort. There's really two types of clustering that we're going to talk about today, or really two methods. The first method is called host clustering, and you can see from the diagram up there that in this case, what we're doing is we're clustering the physical hosts, could be two or more. The cluster service itself runs inside the physical host and manages the VMs, and the virtual machines can move between the cluster nodes. This is a method that I think should be familiar to most people here. And then the second method we're going to look at is called guest clustering. And in this case, we have multiple hosts, but the clustering is actually done at the layer of the virtual machines themselves. So the cluster service is actually running inside the VMs, and the apps and services inside the VMs are managed by the cluster. And in this case, it's the application that moves as opposed to the virtual machine. So let's talk a little bit about host clustering. The point of host clustering, of course, is to eliminate a single point of failure, namely the host itself. So if it crashes, we can restart the VMs on another node. Or if it hangs, we have the ability to restart the VM on the same node. The goal is that for all planned maintenance, that you should have zero downtime. So anytime you need to do maintenance on a node, you can fail over the VMs, do maintenance on the node, and then fail them back as you need to. So that's a really nice benefit. So that can really improve the uptime of your environment. And then, of course, because the VMs are mobile, you can redistribute the load as you need to. So if there's excessive usage on a node, you can move it to another one to ensure you have good performance and sort of load balance the way you organize your VMs. In guest clustering, an essential piece is that we have to be able to monitor the application and its health. So if the app crashes, or the service, as the case may be, or hangs, then we need to be able to detect that quickly and move it over to another virtual machine. The application in this case is mobile, but it's actually moving from one VM to another. So we're not picking up the VM and the app together, we're actually just moving the app itself. And that way, if you need to do maintenance on the guest virtual machine or the VM itself, then you can do that and make changes to it without impacting the availability of that app.
And we're talking about the same technology for both types of clustering here, aren't we?
That's right. It's the same underlying cluster service, the same built-in capability in Windows clustering, but we're just doing it at a different layer, essentially, and therefore there are different benefits to it. So just to give you some sense of comparison, this is sort of a breakdown of the difference between guest and host clustering in terms of health detection. What you can see is that in both methods, we can monitor for hardware failure of the parent, failure of the VM, or failure of the guest OS. But the main difference in guest clustering is we're also monitoring against an application failure as well, which is extremely important. So just to quickly summarize, right, host clustering is where the VMs themselves move from server to server. There should be zero planned downtime to move a VM. So any maintenance that you do, you should be able to do without interrupting the availability, any maintenance on the host. And host clustering can work with basically any application or guest OS, essentially. With guest clustering, we're moving the app from virtual machine to virtual machine. So in this case, there may be a small amount of downtime when we're moving an application. It depends a lot on the app and the time it takes to fail that app over. So that's very important. And another consideration is that in guest clustering, you need to have double the number of virtual machines that you normally would, because you've got the active one where the app is running, and then you've got the passive one where the app is not running. So that can increase the load on your system. So you have to plan for that.
I suppose the biggest way I think of the difference between these two is host clustering makes the underlying hardware of the virtual machine highly available, but it doesn't protect anything against the operating system. When we use guest clustering, we're actually making the operating system itself highly available. So if something actually goes wrong, the operating system hangs, then the application knows to move around in that sort of environment.
Exactly right. Now, some of you might be saying, well, those are great methods, but honestly, there's some trade-offs there. I'm not really sure that meets my full requirements. What do I do if I want to get a little bit of both? And the answer is, good news, you can do that. You can actually combine them together and get the best of both worlds. So you can cluster the physical hosts, and then you can create a guest cluster with the VMs. So the VMs will have high availability. They'll be able to move between the nodes, and you can do application service and high availability so the app can move across from VM to VM. There is a slight increase in complexity in terms of how to set that up, but Phil's going to show you how to do that today, and I think after that you'll find that it's really not that bad. Now, you can mix both physical and virtual inside the same cluster. This is an interesting scenario. It is supported. One of the key things that you need to make sure you do, we'll talk about this a little later, is make sure that your cluster, however you build it, passes validate. That's a really important requirement. We'll talk about that more. If you mix physical and virtual in the same cluster, iSCSI storage is required. We'll talk about that a little bit later, but essentially, whenever you're doing guest clustering, you need to use iSCSI storage. So a scenario here where you might mix the two would be if you have a cluster with multiple nodes and a number of those nodes are just standby, they're not running any workloads. And what you might want to do is actually take those nodes and make them virtual, so that way you're not having a bunch of hardware sitting idle all the time and not being used. So it's a great way to save money, but still provide some great high availability scenarios.
And it is a bit of a business decision too, because quite often, if you're running a physical server to run your SQL performance stuff on, or you've got your Exchange databases on, and you're going to fail over to a virtual node, quite often that virtual node will be smaller, or might even be in a situation where several clusters have failed over that same piece of hardware, and so they run in a slightly degraded mode. So that's a business decision, a trade-off for, hey, we can save a whole heap on the hardware that we had before, but we have to accept that we might run into a degraded mode when we're in a failure situation.
Now, there's a large number of workloads that we support for guest clustering. I'm going to go through a few of them today because I think ultimately the application is really important. If you want to guest cluster SQL, we support both SQL 2005 and 2008. Guest live migration and quick migration are supported, and I've included some links in the presentation that you can see there so you can understand the exact supported scenarios and what's required for each of these. They can be a little bit detailed, so rather than go through them in depth, I've just given you the links. So if you want to set it up and do it yourself, you can actually read about what's required. File servers are another one that's very common. What's great about that is that you can live migrate your file server to a different physical system, And that shouldn't even break a TCP/IP connection. So if I'm downloading something from a file server, as an end user, I shouldn't even really notice any significant problem if that file server gets failed over. So that's a good thing. And then, of course, for Exchange, we support 2007 SP1 for guest clustering and 2010 SP1. There are some caveats and restrictions on which configurations you can do, especially in 2010 if you mix it with DAGs. So definitely I encourage you to take a look at the article there. It's about a page long, and it gives you the details on how to do that. And then we support many other server products for failover clustering, and I've included a KB article at the bottom. There's a very long list of all the supported apps. I find that's a really good reference because that's a question I get a lot. Do we support this application for clustering and for high availability? And that'll tell you all about that.
Quick show of hands of who did clustering with Windows Server 2003. Ooh, a lot of hardcore people.
Quite a few, all right.
So we know that wasn't the best experience. And as such, clustering got a bit of a bad rap. And one of the easiest things to do in 2008 now is create clusters. And we'll have a look a little bit through the validate process. But a lot of people today are running standalone file servers now. And you think about how mission critical that is to your environment, that file server. Everyone rings you as soon as the file server's down. Now, with virtualization, with Windows Server 2008 and the changes in clustering, we've actually got a bit of a opportunity to take advantage of clustering and bring it back into our environment with that paradigm Harris put forward with the physical versus virtual. You might have a physical 2008 file server sitting there. Why not run up a virtual instance to act as a failover node for that? It's just going to be a lot better environment having that high availability in there because clustering is just so much easier to use now, and it's mission critical, and we've just forgotten about things like the file server.
Yep. So let's shift gears a little bit. I want to have Phil show you how to configure a virtual machine for being highly available.
Thank you, Harris.
Switch over.
So here I've just got a simple 2-node cluster, and I've got some iSCSI targets presented up to this. You can see I've already got some services presented in my failover cluster environment. And from here, I'm just going to create a new virtual machine. We've got a couple of methods that we can create a new highly available virtual machine. First of all, if we've got a virtual machine that's already running, we can go and target that one and bring that in to be highly available. So from here, I'm just going to go into the services, say I want to add a new service. I can see a list of all the different types of services I can add. Again, I mentioned things like the file and print service that are quite easy to add into this cluster environment. Another important component there is generic service. A big change in Windows Server 2008 R2 is this ability to start making any service highly available. So if you've got a mission critical application that runs as a service on a server, you can now start to cluster that. It doesn't necessarily need to be cluster aware. That obviously helps if it's cluster aware and it uses the cluster DLL, but we can now take a generic service, and what we'll do is when we want to move that service, we simply shut the service down on one server, fail the storage over that is attached to that application, and bring it online on the other environment. So we're looking at virtual machines. So if I wanted to make an existing virtual machine highly available, I can come here, select virtual machine. It'll then scan the cluster nodes to find all of the virtual machines, and I can select one of those to bring online. But there's another method as well. We're actually creating new virtual machines and making them highly available. You see inside the cluster interface here in Windows Server 2008, we've got a lot of the Hyper-V components exposed to us directly. And that actually gives us the opportunity to create virtual machines here inside the cluster service and do all the configuration at once. So if I choose to create a new virtual machine, I choose a cluster node that I'm going to create that on. I give it a lovely name. Give it some memory, connect it into my networks. Now, an important thing about Hyper-V clustering and networks, the virtual switches on the different servers must be named the same thing. When you fail a virtual machine from one host to the other host, the cluster resource will try and plug it into a virtual switch of exactly the same name. So it's an important component to make sure that you get those named the right way. Cluster service isn't great at warning you that that's the problem. Choose to put it into a hard disk. We'll put an operating system on this later. Quickly, finish, bang. And now it's creating that virtual machine and the configuration on the node that I selected. but it's also creating me all of the cluster resource components in that environment. It's left the machine online. We can go and have a look at that. We can see the resources that have been attached to that. Now, if we had created this on a LUN that was meant to be moved around with that virtual machine, it will have attached the LUN to that cluster group as well. If we create it on a CSV, that's not so much an issue. We don't have to worry. We'll talk about CSVs or cluster share volumes in a moment. But another component too is if I want to change a LUN, change a server. So I've got a virtual server here. Again, I'm working in the cluster interface. And I want to change the settings of this. I'm going to add a new disk to it. Now, I've got some options to go and create a VHD and add that disk, but I've also got the ability to pass physical disks through to this server. I'll just select disk 5, which is a raw mounted disk for this virtual machine. Now, it's running, but because we've got the SCSI controller attached, we can hot add storage to that. And we'll see that the cluster system has attached that physical drive to the cluster resource group. Now, what that means is when this virtual machine moves over from one server to the next, it will take control of that LUN that's attached to that virtual machine. Just to show you what that sort of looks like, we now see that cluster disk 5, which is currently reserved, and it's been offline because it was on the other node at the moment. Cool. Thanks, Chris.
All right. So let's talk a little bit about cluster validation and support. As Phil alluded to earlier, there were a lot of challenges around supportability with Windows 2000 and Windows Server 2003 clusters. And the reason for that was because the support policy for that platform was as follows. Number one, every piece of hardware in that cluster had to be logoed for Windows, which is not surprising. But then the entire solution, so every component in that cluster, had to be a certified solution by Microsoft for clustering, which was pretty burdensome. So you could, it was more difficult and more expensive to kind of build your own cluster and put it together and get support. And it was frustrating too, because a lot of times you could put together an unsupported cluster and it would still work just fine most of the time. So it was really a kind of a high bar to get clusters supported, and that increased costs. So with Server 2008, we changed our support policy for the better. And basically now we've relaxed that second requirement. So you don't have to have a fully certified cluster solution. You just really have to have two things. Number one, every piece of hardware has to be logoed for Server 2008 R2. That's, again, pretty normal. And then the second thing is that your cluster needs to be able to pass validate, which is basically a series of checks that I'll show you. So now you can go out and buy commodity hardware. It doesn't need to be a special list of 10 different configs. So pretty much any commodity hardware logoed for Windows 08 R2, and that's all you pretty much need to do if you can pass validate. So what does validate mean? Basically, this is a tool that we built, and it verifies interoperability. So you can run it after you configure your cluster or even post-deployment, and it's really like a best practices analyzer for clustering. So it does a bunch of end-to-end tests on all the different components of the cluster, and it checks for poor configurations, anything that goes against recommendations, network issues, and things like that. Basically all the learnings that we've acquired over the years from people running clusters. And basically gives you a really nice report, and it tells you if your cluster is certified or not, basically. And if you pass that check, then your cluster is supported. Simple as that. So what I'll do is I'll turn it over to Phil, and he'll show you a quick demo of what cluster validation looks like.
Cool. So when you first install Failover Cluster Management Console, you come to this landing page, and the first couple of things you can see there are validate cluster, create cluster. If you decide to bypass the validate the cluster component and go straight to create cluster, it will prompt you to validate the cluster. So if I'm going to validate from here, it's going to ask me to select a bunch of servers, and I can enter those server names and go and validate those servers together as a cluster. Now, it will, during that validation process, do everything that can happen to a cluster, right? And that includes one server holding onto a disk and another server trying to take that disk off it. It'll include a server releasing a disk and then another server picking up that disk. Now, that doesn't sound too onerous, except if you have a 16-node cluster with a couple of hundred volumes, the permutations of 16 cubed or whatever, we have to get Adam to come and work that out. that can take a while. So if you build a huge cluster, expect that validate is going to take a while to run. The other thing you might want to run validation for is when I've got a cluster that's actually running, I can run validate against this cluster. If you have concerns about what's happening to the cluster today, you can run validate against a live cluster, and it will warn you if you've got live components on there, and it won't take them down. So here, I'm going to select validate cluster. Now you may notice that this is going to give us a new option called review storage status. So I'm going to choose to run all tests, and it said, hey, you've got this service online at the moment, and it's going to lock certain components that I can't validate. Now, I'm not going to take that offline unless we specifically tell it to take this offline and now validate the entire cluster. What that will mean is if you are using the disks on that cluster at the time, you're not going to validate how the storage is working. The way you can get around this is just pass up a small LUN, a small empty LUN that's not being used, and the validation will run against that one LUN that isn't being used in that environment. So you can validate that component. Or you can simply elect to avoid the storage validation passes. Now, once I select off you go and validate the cluster, it's going to start flicking through all of the tests. And the tests are quite extensive. Some of them are quite quick. The storage ones are fairly slow. But while that's going, let's have a look at some of the previous ones. All of our cluster reports, our validation reports, are stored. Windows, clusters, cluster reports. From there, we can have a look at the HTML version of any of the validations that I've run previously, and they're quite detailed. Here I can see that I haven't actually done anything about that. Here we can see that I've got on most things, I've got some warning on others, and I can go click on the hyperlinks, find out, hey, I got a warning on my network communications, and as you can see, I've only got one NIC in these servers, so it's sort of giving me a couple of warnings around that, but it's still passed validate overall. Now, the other thing, you might have trouble with running validation. You can turn on advanced debugging inside the event viewer. If you turn on diagnostics in event viewer, you can see a lot of components about validation, but it will only show you the validation that is running on the primary server. It won't show you the detailed logging of what happened on the other servers. To find that, that's actually stored in this text file called validate storage. Now, one warning about looking into this log, and most of you won't have to, is first thing you will find is there are a lot of fails, and they're meant to be there. Because as I mentioned before, we're trying to work out if, hey, this server's got hold of this LUN and another server's trying to take over it, we want that to fail. So that's all inside that text file. But on top of that, you've got a storage validation log for every node. So you really have to mesh those together to have an understanding, but you're really into deep debugging at that stage.
So just to recap there, number one, it's a really important best practice before you deploy any cluster to make sure that it passes validate. And if you have a potential support issue with any cluster, your first course of action should be to run validate. Whether you do it before or after, if you call Microsoft support, that's going to be the first thing they're going to ask you is, have you run validate on the current config? And if so, did you get any errors? Can you send us the report? That's really a good starting point for any troubleshooting for clusters. All right. So let's talk a little bit about PowerShell. With Server 2008, we introduced PowerShell, which is a great tool. It can also be used to manage clusters, no surprise there. But you can do quite a bit with PowerShell that you couldn't before. You can run validate and script that with PowerShell. You can create a cluster from the ground up using PowerShell and configure high availability. You can generate a dependency report to understand what are all the resources on your cluster and to make sure those dependencies are set up right. And we even have help. So what I've done for just your assistance is there's some very common commandlets that are there that you might use when you're managing a cluster with PowerShell, which hopefully you'll find useful. One little note about PowerShell. In this current version of clustering, we really have two ways to manage it via command line. One is with PowerShell, and one is with cluster.exe, which has been in the product for a number of years. So for those of you who use cluster.exe, I just want to let you know that this will likely be the last generation that will be an available mechanism. So moving forward, the direction is to use PowerShell for managing clusters. So if you haven't switched over to using PowerShell for managing your clusters, now would be a great time because its lifespan is somewhat limited. All right, so now let's talk a little bit about live migration. So we'll just go through a quick scenario to explain how it works. Some of you are probably already familiar with this. So in this case, we've got two physical nodes. We've got a virtual machine running on node A, and the administrator head decides that she's going to live migrate the VM. So she would initiate that from the console. And then what will happen is the virtual machine is going to get copied. The contents of memory are going to get copied over to the new server and pre-staged. So we're going to do that while the end user is still connected to the primary node. So they're not going to notice any of this. This all happens in the background. And we're going to continue to copy that memory. Now, while we're doing that copy, if it's a large VM, it could take a little while. That client may be accessing that VM and may be making changes. In fact, it's pretty likely that they will. And while they're doing that, what we're going to do is we're going to keep track of any change that's made and mark that page as dirty. So we're keeping track of the changes that are made on the primary node that haven't been copied over. And you can see those represented with little red dots. Those are the dirty pages. Okay? So we're going to do this iterative process where we'll copy it over, then we'll go back and look for the new dirty pages and copy them over and keep copying until eventually that set of dirty pages is going to get down to a very small value. And then once we get to that point, then what we'll do is we'll momentarily pause the VM, okay, and redirect the client over to the new host. So in that brief period, right, one of the questions that comes up is, is that really high availability? Isn't there a period where my VM is not alive? Isn't that a problem? And the answer is yes and no. So it really depends a lot on the traffic that you're dealing with. If it's UDP traffic, for example, you could lose a packet or two, and that wouldn't be the end of the world. If it's TCP, TCP's got a built-in retransmission mechanism. So if a packet or two gets dropped, TCP will automatically retransmit that. What we do in live migration is we make sure that the time when that VM is paused needs to be shorter than the TCP timeout window. So that way, the end user experiences that they have a seamless connection, and they won't get any errors or disconnects or drops and things like that as far as they can see, even if we do lose a packet or two in that momentary period. So it should be a very, very small interruption from the state of the end user. They shouldn't really notice it. So once we get the client redirected to the new host and they're up and running and we confirm that that's successful, we use ARP to update the routing tables, and then we delete the old VM on the other host. Session state is maintained. There shouldn't be a need to reconnect. Again, the end user shouldn't notice that process. All right. Let's talk a little bit about deployment planning. So the first decision that you'll probably want to make when you're building a cluster is what should I use for my host operating system? There are different variants of Windows that have different levels of capability when it comes to virtualization and clustering. One that's not very well known, but I think is quite important, is something called Hyper-V Server, which is not Windows. It's Hyper-V Server, full stop. But basically, it's a free download that you can use as your host OS. So what it is it's the Hyper-V and virtualization components of Windows with essentially everything else stripped out. So it's a free download, and you can run it on anything from a 2-node to a 16-node cluster if you choose to. It doesn't come with any rights for a host OS. So you do still need, for a guest OS, you do still need a license for your guest VMs. If you're running Windows, those will require a Windows license. But it's absolutely free, and it's a great solution for customers that are looking to build very low-cost environments. Step up from that is Windows Server Enterprise. That's a full version of Windows Server. It's licensed on a per-server basis, and it includes the rights to run up to 4 guest operating systems of Windows. So the benefit there is instead of having to buy 4 copies of Windows for your 4 VMs, you can buy 1 copy and cover all those under that license. So it's a very economical way to license a low-density virtualization environment. And then really the preferred SKU for virtualization in large farms and most enterprise environments is Windows Server Data Center. It's licensed per CPU or per socket. We don't charge per core. And when you apply that data center license to your hardware, it's a minimum 2 procs, which is quite common. Then what that gives you is unlimited virtualization of guests. So if you want to run a very high-density cluster, 10, 20, 30 VMs, whatever you want, all of those are free and included with that data center license. So that's a really economical way for a high-density environment, a large farm, or potentially even a private cloud. And again, with all these SKUs, even though they have very different costs associated with them, they all support Hyper-V. They get the same version of Hyper-V. They support up to 16 nodes and clustered shared volume. So basically everything you need to do virtualization and clustering. Now, another consideration with hardware is thinking about your processors. So obviously, one approach, and I think the old approach in clustering was that every node had to be exactly the same. That was our guidance. They had to be identical down to the last piece. And that's not always realistic or feasible, right? We wanted to give people more flexibility to build clusters and to be able to, later go and buy additional nodes. And what you might find is, maybe you build a 4-node cluster and then you want to buy another 2 nodes. When you go to buy those new nodes, you may not be able to get exactly the same hardware. So in the old clustering, that would have been a problem. In this case, it's not. So our only real restriction here from a processor standpoint is you can't mix Intel and AMD in the same cluster and do failover and do live migration. Other than that, we can support different family model and stepping, which is fine, using something that we call processor compatibility mode, or PCM. You can see where you'd enable that in the current VMM 2008 R2. It's just a nice little checkbox. And what that does basically is it looks at the capability of your CPUs in the various nodes and figures out what's common across all of them. And then when you enable processor compatibility mode, you can ensure that you can fail from one node to the other, and you're not going to run into any problem where we try to execute a command that processor doesn't support. So even if it's an older processor, it'll be able to run in a cluster with newer ones. If you've got a question about whether your processors are compatible, we've got a great tool here on MSDN that you can run. It's a little wizard. It'll actually go and scan your environment and figure out if they are compatible or not.
A lot of people ask me whether that's going to be a big performance hit, turning this on. And it only masks out the advanced chipset features that have been coming in the later years. Now, you have to make an intelligent decision about whether your applications are actually using that in the environment. For example, if you're running something that was doing a lot of SSL offload or anything like that, a lot of the cryptography, it's probably going to take advantage of the cryptography settings in some of the newer chips. However, for the majority of workloads that we see, they're not taking advantage of these parts of the chips. So enabling that and then moving it from the different servers won't severely impact those applications. They're really just using that raw performance compute power.
This one I get a lot of questions on, which is planning the network config. And it always comes in the form of, how many NICs do I really need to do clustering? What's the recommended guidance, or what's the minimum I can get away from in some cases? So this is the basic rule. The minimum is 2 networks. Okay, that's the bare minimum. One would be for your internal communication and live migration, and the second would be for your public access and management of your virtual machine guests. So that's the minimum that we'd recommend. Obviously, what you can see in that configuration, we're doubling up in terms of the usage of the networks. So the best solution, the one that would deliver the best performance, is one where you actually break out those network roles and they each have their own network. So it can be anywhere from 2 to 4. So if you take that best solution, you have 1 for public network, 1 for internal, 1 for live migration, and 1 for management. And that way you can ensure that the traffic is truly isolated and you get fantastic throughput. An optional 5th is in the scenario where your storage is iSCSI, in which case instead of having an HBA, you have an iSCSI adapter, and that one should also be its own dedicated network. So potentially you could have up to 5 in a recommended configuration. And then what you do as you have multiple networks is you'd set up network prioritization, so you can ensure how the networks are used, and therefore if there's a problem with one of the networks, how that failover would occur. Finally, in terms of storage, this is another one where I get a lot of questions. In host clustering, going back to our earlier discussion, we support fiber channel, serial attached SCSI, fiber channel over Ethernet, which is a new one, and of course iSCSI. Now with guest clustering, if you were really observant in my diagram a while back, you notice that every example of guest clustering uses iSCSI because that is the supported storage mechanism for that technology. Virtual machine density is another important consideration. I get this question a lot around, how many can I really run? What's the practical limit? So here it is. It's 1,000 VMs per cluster are supported. You can deploy them across any number of nodes, anywhere from 1 to 16. What I'd recommend, of course, obviously, is you want to have at least 1 spare node. So if a node fails, you can actually deliver good performance. So 1 is the minimum. More is always a good thing. We can support up to 384 VMs per node at a given time, and 512 virtual processors per node. Those are the limits. So those are quite high. I've never seen a customer run up against those limits, although I'm always welcoming someone to challenge me and tell me that they have. But I don't know anyone who's doing that kind of density today. So you should think about how many nodes, how many VMs per node. Think about failover scenarios and how that would work. But again, I think practically speaking, for most people, the hardware is a greater limitation and the costs are a greater limitation than the actual limitations of Hyper-V.
And we really only see people running into these sorts of numbers with VDI type scenarios. And we're talking pretty high density. If the recent performance report came out, again, putting us above a certain unnamed hypervisor, getting much higher density around VDI type workloads. And in that sort of situation, you're probably going to have a look at more than 100 servers per host or 100 guests per host. And in that situation, you've got to start thinking about maybe I'll just lower the number of cluster nodes down. Maybe I'll just run an 8-node cluster for my virtual desktop environment. Or if you're using things like Citrix and their presentation server componentry, you might look at things like just actually not using clustering at all for those virtual machines. If we're providing up pooled desktops, then we can just provide standalone nodes, and these clustering limits really don't sort of hit us at all then.
All right, so the last topic I'll cover on planning is around clustered shared volumes. And this is really around how you can permit multiple physical nodes to simultaneously access a common volume or common storage infrastructure. Really, the goal here is to simplify the way you configure storage, to not piss off your storage people, which is really important, and just to increase the overall resiliency of the solution. So how do they work? Basically, they provide distributed access for Hyper-V. So multiple nodes can concurrently access a single disk or LUN at a given time. With clustered share volumes, the virtual machines don't know who their host is, and they're no longer bound to a particular storage, which is great. So what that means is that virtual machines, multiple virtual machines, can share access to a CSV disk and reduce the number of LUNs that you have. So if you think about kind of the old way we used to do this, if you're familiar, the guidance was that you could only access one node could access one LUN, and therefore one VM. And so what you had to do is we'd said, well, you should only have one VM per LUN, right? And so the virtualization guys would go to the storage guys and say, well, yeah, I need you to cut up the LUNs so that it's one VM per LUN. And they'd say, no, I have these really big LUNs. That's super wasteful, very expensive. I don't want to recut the way I do my storage. Let me do my job the way I like to do it. And so we said, no problem. With clustered share volumes, you can have one massive LUN if that's what your storage guys want. You can put multiple VMs on it at a time. It's absolutely no problem. So I'll give you a little diagram to kind of show how that works. In this case, we've got a massive LUN. Let's say it's terabyte, if you like. We've got multiple VMs running on it and multiple hosts accessing those VHDs at the same time simultaneously. In terms of compatibility, CSVs are fully compatible with what you have today on Server 08. So there's no special hardware requirements. There's no file type restrictions. There's no mysterious directory structure or depth limitations. It's exactly like NTFS. So any limitations you have on NTFS, that is what we support for CSVs. You don't need any agent. There's nothing proprietary. If you use file system management tools in NTFS, they're going to work on a CSV. In fact, it's pretty hard to even tell when you're working with the CSV. It looks just like a regular NTFS volume. So I'll let Phil give you a quick demo of that. You can see what that looks like.
So we'll have a quick look at live migration and CSVs. First of all, I've got this virtual machine, which I'm just going to live migrate. It's currently on STU13, and I'm going to move that over to the other node, STU11. Now this is going to move over fairly slow. I've only got one NIC, poor little PCs that are running this. But you can see the current owner of the cluster shared volume that this box is on is actually owned by the other server. So when we move this, the ownership of the CSV won't change. Now the migration will take a little bit of time, but the machine's up. We're just doing the memory copy, getting the configuration ready, going a couple of run-throughs. This runs a lot better in a server environment. You've got a lot more NICs, or probably a dedicated live migration NIC as well. And now that machine's over on ASTU11 and running along quite happily. Now I can also live migrate servers that aren't on CSVs. I can live migrate servers that have cluster share volumes. Here on this machine, it's attached to a cluster disk, which is mapped as a physical drive, as an F drive on this machine. And you can see it doesn't state the owner here, because like it did for the cluster share volume. And that's because this LUN is implicitly owned by the same resource group. So it's owned by 13. And we also had that raw disk that I added before that's being directly accessed by the server. Now, when we do the live migration in this environment, I'll kick it off so I can do the memory copy. Sorry. When we do this live migration, it's going to get that memory across, but then at the end, it will actually have to move the disks over to take ownership. And it's a little bit slow on my iSCSI environment here, but that means we can actually see that it's bringing those disks online, and then it will actually start the machine back up and running. So in a real environment, you sort of don't get a chance to sort of see that happening underneath your eyes. But how do we configure cluster share volume from a normal cluster? Once we've got the cluster up and running, we have to do this extra step, which is just a little bit hyperlink down here. Enable cluster share volumes. Normally you're prompted with a dialog box that says this is what cluster shared volumes are used for, which today is virtualization. And then you say yes or no and enable it. Once it's enabled, you can then come down to the cluster share volume area, which will appear in the interface, and add storage. So if I'm going to go into the add storage, I currently don't have any disks, so I've just taken up my last raw disk, but it will give me a list of all the cluster storage that's available there and formatted with NTFS, and then I can actually add that storage in to be the cluster share volume component. Cool.
Great.
Do you want me to talk a little bit about the fault tolerance?
Yeah, why don't you go through a few scenarios.
So a lot of people start to ask, and we actually had some questions before, for those of you that came to the previous session, around what happens around traffic throughput for the CSVs and how do they manage this component. We have the environment where cluster share volumes actually give us higher availability of the storage attached to the host. So in the situation whereby the host loses connectivity to a cluster shared volume, it has the ability to redirect all of the read-write traffic that was going straight to the CSV box across the network through to the other node that actually owns it. And it can make all the reads and writes for it. In the meantime, we've obviously detected that the node's in trouble and we do a live migration and get everything off that box. But what it means for us is that the virtual machines continue to run even when we've lost connectivity to the storage. What if I lose network connectivity between the two environments? Well, if one box can't actually, node 4. What if I lose a full node and that node owns the CSV? I showed you before that each CSV LUN is still owned by a single node. Now, if the node that is owning the CSV fails, the ownership of the CSV moves across to another node, just in normal failure of any resource. The actual LUN itself doesn't go offline for any of the other nodes that are accessing it while this failure is occurring. They can continue to do their read-writes, and if they have metadata changes, which are done by the owning node, they'll actually be banked up until a new owner has been elected, and then from there, the metadata changes will get made. And finally, what if suddenly we lose network connectivity between the nodes for a CSV environment? So we're making metadata changes across the network to the primary owner. If we lose network connectivity to the primary owner, well, clustering itself will actually fail over networks across the different networks in their environment. So that's not an issue for us either.
Yeah, and that goes back to my earlier comment on why you want to have a minimum of 2 networks. That way you can survive if that network goes down. All right, so to conclude here, there's some really important considerations when you're planning the number of virtual machines per CSV. There is no maximum limit, so there isn't a limit that CSVs can handle. It's not a software issue, but there are some practical considerations. So number one, you want to make sure you have good performance, right? So you want to test that and monitor it to make sure it's adequate for your end users. Bear in mind, you're having potentially a large number of servers hitting the same one, so you want to make sure that your storage vendor tells you that it can handle that load and the number of IOPS for the storage array. So hardware vendors are usually really good about this kind of stuff, so definitely consult with them before you build your environment.
And one of the, a good example of where you might start to limit the number of virtual machines that you'll have on a CSV LAN is when you have to do maintenance on that CSV LAN, obviously you need to, also no, not obviously, let me explain. When you do maintenance on a CSV LAN, the primary owner of it needs to take full control of the LAN. So we don't want all of the servers writing to that one LAN at one time. We want to just get one node that's going to access that LAN and make the changes. If we wanted to extend a LAN, for example, we would put the LAN in maintenance mode. At that time, all of the read-write operations, or while it's in maintenance mode, would be redirected from the different hosts back through the owning node. Now that shouldn't be an extended period of time because we've got, we can do SAN extensions quite quickly, but if we had all of our virtual machines on that one giant LAN and we needed to extend it a little bit more, obviously the impact of putting that LAN in maintenance is a lot bigger.
So the last topic I'll cover on planning, which is a really important one, which is Active Directory. So if you build a cluster, whether it's 2 nodes or more, all the nodes have to be a member of a domain. In fact, the same domain, which is very important. Every node has to be able to access a writable copy of the writable domain controller. So it cannot be a read-only DC, it's got to be a writable one. You can run DCs on your cluster as VMs. That's quite all right to do, but make sure that your DCs are not all on the same node, because if that node goes down, you're going to lose Active Directory. So that's I think, fairly obvious. There's a KB article on that. And I strongly recommend that you not virtualize every domain controller in your environment. And here's why. In order for your cluster to come online, it needs to be able to identify and talk to Active Directory and do authentication in order to start the cluster service. If your cluster crashes, maybe you lose power, or there's a huge problem in your data center, you won't be able to bring the cluster back online if all your DCs are virtualized and they're offline too. So it's always a good practice to have at least one domain controller that's physical, separate from that environment, on bare metal, so you can bring the cluster back online and then bring all your other DCs up. So a couple of customers have gotten into trouble on that. That's a really good best practice.
And it's not necessarily the cluster that you've got to wait for the DC. I had a customer where they couldn't bring up their SAN online because they didn't have a domain controller up and running.
Yeah, that's right. So it's always good to have one, emergency DC just in case. So I'm going to turn it over to Phil. We're going to talk through some VM failover policies for a few minutes.
Thanks, Harry. One of the things we get questioned about a lot is how do I stop 2 machines that have the similar workloads and are failing over on each other, how do I stop them from landing on the same host? And we do have that ability to do, but it's not actually exposed in the GUI. It's through a command line option called anti-affinity. And what anti-affinity does is it alters the failover properties. So what we do is add each of the nodes, each of the virtual machines into a single anti-affinity group. And from there, when we fail over those virtual machines, we'll make sure that they try and land on a host that has got no other machines that are in that anti-affinity group. You might have 5 domain controllers on a single cluster and 6 nodes in that cluster. You add all 5 domain controllers to the anti-affinity group, and we'll land them on different hosts as they fail over. However, in the situation where suddenly you failed 2 of those hosts, you only have 4 hosts left, but 5 virtual machines to actually run. We see getting that machine running a priority over anti-affinity. Now, anti-affinity is a failover property inside the cluster service. You have to go to the cluster to configure it. I'm going to talk a little bit about VMM later on, but VMM has a component in it called intelligent placement, which is not going to sound too flash in a minute. Intelligent placement chooses where to put new VMs. So if you decide you want to move a VM, intelligent placement gives you a really nice star rating. It does a great job of performance and components like that. Intelligent placement does not know about anti-affinity. Right? It's something we know we need to do better on, and trust me, we're beating up the VMM team around changing that. The auto start setting is a feature of the, we'll just switch back to the demo so we can see where to find these bits and pieces. So if we go to the properties of our nodes, we can see here are our preferred owners. I can tell the cluster service to only put virtual machines on certain hosts. if I tick these boxes, it will always try and put that virtual machine or that cluster resource on those hosts. For example, in this environment, if I tick that and set that setting, it would always try and put that, that virtual machine on that host. If I tick both of them and I had a third one in that list, it then looks at that wasn't ticked. It will always try to put it on those two, priority of the list. So we can alter where we want things to move up or down. So I can change that round. Now, if none of the preferred owners are available, we still see starting that virtual machine as a priority, and we will start it somewhere else. The auto start feature, which is enabled here on the bottom. Auto start determines whether, when the cluster starts, should we try and start that service. Now, it's recorded in the cluster database whether the virtual machine was actually running prior in the environment. For example, if we stop a virtual machine and the auto start box is ticked and we restart the cluster service knows that the machine was stopped and won't try and restart the virtual machine. However, if the machine was running and the auto start box is not ticked and the cluster restarts, we won't try and start that machine either. You use this or turn this off specifically when you want to have control about turning machines on and off in a failure type situation. The other tick box that's down here as well is persistent mode. And what persistent mode does is when we restart the cluster, will we just try and start this anywhere, or do we try and start it on the host that was last running on? And this is fairly important because if you start up a 16-node cluster environment and it's got hundreds of virtual machines, as soon as you've got quorum on the node set, do you immediately want to try and start every virtual machine on the first couple of nodes that are active and available? Or do you want to bring it up in a more balanced fashion, which is usually what we see from customers? And the persistent mode will do that. It means that when we shut down the cluster and bring it back up, or it has a power failure, when we restart everything, we will try and restart the virtual machine on the node that it was on when it was shut down. VM health monitoring is a little hidden component inside our clustering piece. This will actually check the heartbeat of the guest operating system. On your initial install, this is obviously turned off because we are not, it hasn't got an operating system. We need to actually detect the integration components. Once the integration components are in there, we can then monitor the operating system that's running in that environment, and we'll fail over, oh sorry, that's not true. Sorry, fail over. We will restart the virtual machine on the same host if we detect the operating system has failed. There's nothing wrong with the host as far as we're concerned, so it's a fine place to restart it. We just know that the VM needs to be restarted. So if we detect that the operating system has failed, we'll restart it on the same host. Now, if you're going to start building these layers of clusters, or you're going to start doing multi-site clustering or anything like that, you're going to want to look at a lot of the latency that you're going to experience. For example, if we're going to start to have a guest cluster built on top of a host cluster, we want to have a little bit more tolerance of the cluster heartbeat in that environment, because we're going to be moving virtual machine around, or it might experience some sort of delay when we transfer its storage or something like that. We might want to put a little bit more tolerance. Now, those bits and pieces can be tricked up by using some of the PowerShell and the cluster config components. But on top of that, it's very important to do this when you do multi-site clustering, because you need to take into account what is the delay between one data center and the next for latency. Dynamic memory, I'm not going to talk about too much of this in the cluster environment. It's more of a Hyper-V feature, but it is very useful to getting higher density in our cluster environment, because when we start to fail machines over, we want to use dynamic memory to get higher density. So in the environment where we start up a new machine, there's not enough RAM available, there's dynamic memory running on that system, we'll tell all of the systems to start pushing down to give us enough of the boot up RAM to get that machine started. In a failure situation, we're faced with the fact that we're just going to start a whole heap of machines in different areas. So they'll start fairly quickly and they'll start fairly small because we're just going to go on their bootstrap RAM. If we want to live migrate boxes across from one server to the other, that's a bit of a different case because we've got a server that might be using 8 gig of RAM. When we want to move it to another server, we have to push that right out because we want to make sure that this got 8 gig available to it. Once it's over there and running, we can push its RAM down. But when we have to move a server across as a whole and during a live migration with dynamic memory, we have to move all the memory because we've got to work with the operating system inside that system to change things. Now, root memory reserve is about keeping a part of the operating system memory available for the host OS. In Windows Server 2008, we didn't do a great job of this. R2, we got a lot better. Service Pack 1 really takes this up a notch. So with Service Pack 1 and dynamic memory, we work with the guests to open up the amount of memory for the host is more of a dynamic setting. It's no longer a fixed, huge chunk of memory. We actually work as a percentage to make sure that that guest operating system, or sorry, the host operating system can take the memory it needs rather than having just a set segment. Now I want to quickly talk about refreshing the VM configuration. Who uses Virtual Machine Manager in this room? Cool. Who's been extremely annoyed by that unsupported cluster configuration message and had trouble getting rid of it? Yep. There are a couple of things that, because VMM actually looks at the cluster config in a lot of detail to get an understanding of it and doesn't do a great job of fixing issues when it finds them. You can get that message for several reasons. One of them is having different name switches in the environment. That's a good example. Another one is having static files that aren't part of the cluster configuration. So you might attach a DVD-ROM to a virtual server that is actually attached, that is physically attached to that physical node. Now, VMM sees that and goes, I can't fail it over because I can't detach that resource because it's physically attached to this box. The other thing that will give you this unsupported cluster configuration is the fact that the Hyper-V database or the configuration of the virtual machine is out of sync with the cluster understanding of that virtual machine. Now, before I showed you the fact that I can go and create properties of Hyper-V inside the cluster interface, and that is the recommended way to do it. If you are managing, that is the recommended way to do it if you're just managing using Hyper-V. Using VMM, it's doing a lot of this, and we'll talk about that in a minute. If you go and modify the virtual machine, the Hyper-V virtual machine, inside the Hyper-V manager interface, outside of the cluster interface doesn't see a lot of that. And that's when the database between the cluster interface and the Hyper-V interface gets out of sync. You can fix this quite quickly by right-clicking on the virtual machine inside the cluster interface saying update configuration, or even better, you can run the PowerShell script that says, hey, list all my virtual machines and just run the update virtual machine configuration commandlet, which rushes through the cluster for you and gets it all done. There have been huge updates with clustering over the years. With the Service Pack 1 release, we got a lot of hotfixes in there, but we didn't get them all. And in fact, there are a couple more since we first built this slide. There's a couple more hotfixes that you need to get on that system. The best thing to do here is to follow the, I'm going to call it the Wolfpack blog, but it's the Cluster Services blog on TechNet. It is a fantastic blog. Harris talked a little bit about the networks, and I think we've got some of the network stuff coming up. But they're really great articles there. They constantly update on this hotfix is out for these reasons. Very important to keep up to date with those. Multi-site clustering with Hyper-V, not a problem. We recommend that you do this with good storage vendors or with good hardware vendors. And the reason for that is we handle all of the Hyper-V configuration and moving things across site, and the cluster interface has got a good hold of that. The storage component or storage replication between sites, that you need a good storage vendor to do that. People like HP have special DLLs that become part of the cluster configuration that work in with the live migration and the movement of these services from site to site. So that handles a lot of the storage replication and getting things up and running. In fact, the HP one's quite nice. in the fact that if you're running asynchronous replication between data centers and you choose to live migrate a server from one data center to the other, it will identify that, it will pause other replication and burst async replicate that machine across storage-wise so it can get there at the same time as the memory and all of the other components. So you get true live migration between all those environments. So we talk a little bit about Virtual Machine Manager now and some of the changes that it has for clustering. And an important component that not many people see is a thing called quick storage migration. Quick storage migration isn't live migration. It isn't true storage vMotion as VMware use. It does take a small amount of outage. But one of the great things that quick storage migration does, it allows us to move from one completely disparate environment, not storage set, but a completely disparate environment, hardware nodes, everything, to another completely disparate environment without having to change anything. It will copy all of the storage across while the machine is running, takes a snapshot of the virtual machine, starts copying all of the storage across while the machine's running, stores all the deltas in the environment, and then brings the server to sleep for a second, copies the last of the deltas of the storage and the memory across, and starts the virtual machine on the other server. Now, this could be going, and why this is really good for clustering, if you've got a bunch of standalone servers today and you want to move them into a cluster type environment, you can use quick storage migration to take them from direct attached storage onto SanDisk. From a standalone Hyper-V server to a full clustered environment. Or the other way around, from a cluster environment back to standalone server, or from a branch server back into your data center. Quick storage migration helps you out with all those components. Intelligent placement, as I said, not quite as aptly named as it should be. It does a really great job. And when this feature first came out, there was a lot of talk about it, and I sort of glossed over it. And I didn't do it justice. When you've started to use that, and the guys that have got VMM in their environment will know this, when you start to use intelligent placement, you just take it for granted. It fixes a lot of things. When you've got 4 or 5 clusters running and a couple of standalone machines, and you just say, hey, get me a new virtual machine, it finds where to put it. It knows what storage to put it on. It finds out which of your clusters are least used, if it's got to be highly available, or it will sort between clusters and standalone machines if you said the machine should only be standalone.
Yeah, it's a really important piece if you want to do a lot of automation. And it's an important component of a private cloud as well.
I just like it because it saves me a crap load of time.
Yeah.
System Center Virtual Machine Manager 2012 has brought the level of cluster integration up a new notch. It will actually build your clusters from bare metal now. I'm not going to spend much time here. I think there's some guys that are actually doing this in one of their demos. But basically, the vision is now you get a huge pile of servers, you point VMM at the ILOs or the IMIs or the DRACs or whatever's in those servers. Say, go and put Hyper-V on them. Here's the profile. Make it all highly available as a cluster for me, and it sorts all of that out. It will also manage the different disks it's attaching to. It will slice off the storage and add that into the cluster for you through the SMI, that provider thingy. Harris.
Thanks. All right, guys, we're getting close here. So just to sort of sum up what we've showed you, right? High availability and virtualization are not two separate things. They're separate components in Windows, but they can go hand in hand, and they can be managed and architected together. There's a very tight integration in the current release of Windows Server between Hyper-V and failover clustering. Phil showed you some examples of that, which are really interesting. Host clustering is a technique to allow you to achieve zero downtime for all planned maintenance. So if you're not using that and you have an environment you want to make highly available, I strongly recommend you look at host clustering. If you've shied away from it before because you thought it was too complex, too costly, or things like that, hopefully we've convinced you otherwise. And if you want to build highly scalable, large number of VMs and manage them all in an automated way, Virtual Machine Manager is a really great way to go, both in the current version and it'll get even better in VMM 2012. So we've got a few resources here that I recommend if you want to read more. The cluster blog that Phil referred to is there, and a variety of really good technical resources. What I think I'll do now is just a quick reminder, please fill out your surveys. You have the potential to win a Windows Touch Mouse. They're very, very nice, 10 drawings a day. We really appreciate your time today and coming to our session, and hopefully you'll give us great evals, and we'll get to come back next year. So with that, I'll pause, and we've got about 10 minutes left to take any questions that you guys might have. So if you just raise your hand or call out, I'll do my best to see you in the large room. Got one here in the front.
With Hyper-V's live migration, if you were to do a ping minus T command on a virtual machine that you're about to do a live migration, from a client's perspective, if you're watching those pings on the screen, will you notice any ping packet drops?
Yep, it's a great question. So the question was, if there was a continuous ping set up to a virtual machine that we're live migrating, would you notice any pings dropped? The answer is I've tested that actually. You will likely see that maybe a few will be dropped. So there could be a momentary period where a ping or two might time out. And that's okay, right? We know that's going to happen. You might lose a packet or two. That's normal. But what should happen is you shouldn't lose more than what would be required for TCP timeout. So TCP should be able to recover from that and say, oh, I lost a packet or two, no problem, I'll resend them. Those will go through just fine, and the connection will be uninterrupted. So if you look at that micro level, you could see a few drop packets.
So it's 1 or 2 packets, because I think in older versions it was like 10 or 20 packets or something.
Well, I'm not trying to give you a guarantee
If you're talking about if it was quick migration was obviously a lot longer. So quick migration did have downtime. We were saving the state on the machine and starting it elsewhere. And you can still do quick migration if you really wanted to. But live migration is within sub-second time. So because ping's not using TCP, you'll see drop packets.
Yeah.
Yes, sir.
What's your recommendations for antivirus on the host?
My recommendations for antivirus on the host, my recommendation is the Hyper-V Security Guide. Good document, covers off antivirus as well. Being a Microsoft person, I'd like to use Forefront because it's so light and smart, and Jamie's sitting in the front row and is a Forefront expert.
Yeah, I was going to say, we've got a session on Forefront Endpoint 2012 tomorrow at 11 something. And one of the key things when you're setting up antivirus on anything, including a cluster or a virtual machine or anything like that, is to make sure you get the exclusions right so that your AV is configured properly. Now, to be frank, you can do that with any product, right? Any product you put in the right exclusions will work. But one of the nice things of FEP 2012 is that we already build them in for you. So you just pick, oh, this is the workload, and it automatically builds all the exclusions out for you.
The security guide has all of the exclusions and has folders.
So it's really just a question of if you want to do them manually yourself or you want them to be done for you. But they can pretty much work in any product. You just have to make sure you get the paths right.
There's a question out the back there, was there? No? Cool.
Anyone else? Hands?
Yes, sir.
You're talking about having automatic detection of operating system health and restarting before. Does that only work on Windows OSs?
No, sorry, the question was, with the OS detection or OS health, can't remember what it was called, OS state detection, do we only work with Windows OSs on that? And the answer is no. That uses the integration components. So if you've got the Linux integration components installed in that, which were just released a couple of days ago with a new version, then we'll detect the state of that OS as well.
Yeah, and we support multiple different variants of non-Windows operating systems.
Cool.
Any other hands?
All right, with that, Harris and I are down here for a couple more minutes if you want to come down and ask some other questions. But thank you very much, guys.
Thanks a lot.